Okay, we are going to finish up 6B by looking at an example where we're going to do all kinds of things. We're going to create a histogram. We're going to find the mean. We're going to find the median. We're going to find all of these different things. We're going to look at skewedness and look at how the different types of data relate to each other. Okay, so I looked at the average rainfall for Austin and for Portland. Portland is where I grew up, and it's interesting that the two cities have approximately the same amount of rainfall each year, but it's spread out very differently, so it compares a couple of different things. Okay, so the first thing is, you can cross that off. We're only going to be looking at rainfall, so all we're going to look at is the bin size of 1. Okay, so average rainfall in Austin, average rainfall in Portland. So this is going to be, and I'm assuming these are in inches, I should have said that. So this is rainfall on both of them, and inches. I can't imagine it would be measured in anything else. And of course, as always, our y-axis is frequency. Which is going to be the number of months. So this is going to be the number of months. Okay. So, okay, here we go. So let's see what we can do here. So it says go by 1. So I'm going to start with 0 to 1. In Austin, there is nothing between 0 and 1. Okay. So I'll go from 1 to 2. So let's see what we can do in the 1 to 2 inches. So we have 1, 2, 3, 3. So between 1 and 2 inches, our histogram is going to have a height of 3. There are 3 months where the average rainfall is between 1 and 2 inches. All right, let's do 2 to 3. So there's 2, 2, 2, 2, 2, 2. Whoops, and I didn't make this quite tall enough, so let me fix my graph. So there's 5, and there's 6. Okay, so from here, I'm going to have to go all the way up to 6, and then back down to 3. All right, then let's look at 3 to 4. There is 1, 2. So from 3 to 4, I'm going to have a frequency of 2, which means a height of 2. Notice since this is a histogram, the bars are touching and they are all the same width. From 4 to 5, nothing. So 5 to 6, we have 1. So 5 to 6, oops, it needs to be just a little bit taller. We have 1. Okay. So you can see how it is spread out. All right. Now, let's look at Portland. All right, let's look at 0 to 1. Let's see. Okay, July is less than 1, so from 0 to 1, there is going to be 1. Okay, let's look at 1 to 2. So 1, 2, 3 of those. Okay, so that's the same for both of them. So the 1 to 2. Okay, let's look at 2 to 3. There's 1, 2, 3 of those. Okay, let's look at 3 to 4. two of those. Oops. 4 to 5. Oh, there aren't any in either one. That's interesting. Okay, let's do 5 to 6. There are 1, 2 of those. And finally, in 6 to 7, there are 1 of those. Okay. Alrighty. Okay, so let's create our 5 number summaries for each set. Now, because I don't want you to sit here and listen to me do all this, remember to find the 5 number summaries you want to put in order. Make sure you list them out and put them in order. If you have technology that will help you with that, that's great. This is going to be for Austin. And this will be Portland. Okay. So to find the low and the high, you're going to put them in order. The low in Austin is 1.89. The high is 5.03. Then when you're lined up and you put them in order, there are 12 months, so you're going to have to find the average of the 2 in the middle, but the median is 2.48. To find the lower quartile, it's the median and the low, so that's going to be 2.07. The upper quartile is 3.36. After you've practiced this at home, if you still are having trouble with it, be sure and let me know. Okay, if I line up all the ones on Portland, the low is 0.6, the high is 6.1. If I find the median, if I start out and count my way in, I'm going to have 2 in the middle. I'm going to have to find the average of those, and the median is 2.55. When I have the median, I'm going to count in and find that the lower quartile is 1.65 and the upper quartile is 4.6. Okay. All right, now we're going to create box plots for both of these. So Austin is on the top. So for Austin, the low is 1.89. So it would be like right here. The lower quartile is a little over 2, 2.07. The median is 2.48, which is just 2.5. The upper quartile is 3.36. That's going to be about right there. And then the maximum is just a little over 5. So right there. So again, you connect the 3 in the middle to form a box, and then connect those to the min and max with whiskers. The low in Portland is 0.6, so that's going to be just a little more than a half. The lower quartile is 1.65. The median is 2.55. It's a little over 2.5. The upper quartile is 4.6. And the max is 6.1. All right, so again, the 3 in the middle are connected to form the box. And the box is connected to the low and the high with a whisker. All right, now if I want to find the mean of the data, remember how I do that. I'm going to find the total of all the values divided by the number of values. And again, rather than, sit here on the video, you can pause it, but you should come up with 2.8 for Austin and 3.04 for Portland. Now notice how the means are related to the medians. Here the mean is larger than the median. Here the mean is larger than the median. That means your data is going to be skewed right. You can kind of tell that from here anyway. There is a lot more here. You can also tell the skewedness if you look at the graph. You can see the skewedness here and the skewedness here. So that's how all of this ties together. Okay. Now to find the range rule of thumb, I'm going to have to find the range divided by 4 to find the standard deviation. Okay. Well, the range in Austin, the range is going to be 5.03, the highest value, minus the lowest, which is 3.14. So if I take 3.14 and divide it by 4, I get 0.785 as my standard deviation. For Portland, the range is going to be 6.1, the highest, minus the lowest, which is 0.6, which is 5.5. So to find the range rule of the standard deviation using the range rule of thumb is 5.5 divided by 4, which is 4.125. Now this makes sense. Notice the standard deviation is very small here, it's larger here. Notice how spread out, much more spread out this is than this is. Oh, and that's the next question. Okay. Based on the standard deviation, which set of data has the greater? Portland, because the standard deviation is larger. Okay. Now again, we don't normally use this for skewed data, but in 6C you'll see that we use the mean and the standard deviation a lot more when the data is symmetric. Okie dokie, the end.